Right. So now I've given you the formula here, but like I say, I mean, formulas are. I mean, I don't know if they. I'm not sure if they give you this or not actually in the exam, but we shouldn't really need it because the concentration, as it says in the unit, moles per decimeter cubed, it means the amount of moles per decimeter cubed. So we shouldn't need to know that it's moles divided by volume. We should just be able to see that just from the fact that that's what the concentration is. And of course, that's what concentration means. But all the same, there it is anyway. Now, as I said, titrations. Titrations are you're trying to work out what volume is needed to neutralize something, and of course the volume's going to depend on the concentration of something. So once you've got the concentration, then once you've got the volume, then you can work out the concentration. So it's all about eventually calculating the concentration. So in a similar way to the other moles questions to do with moles types of questions to do with mass, we're going to identify the target and the known substance. So the target substance is going to be my sulfuric acid, and I've got the volume of my sulfuric acid, but I don't have the. Oh no! Wait a second. Sorry. Hang on a second. So quite often, actually, this is the different way around. Quite often, most of the time, you're trying to calculate the concentration. In this case, you're calculating the volume. That's fine though. So we're trying to work out the volume of sulfuric acid, and we've got the volume and the concentration of the sodium hydroxide. So the sodium hydroxide is this one here, and the sulfuric acid is this one here. In the same way as before, you're looking at the ratio. So for every 2 moles of sodium hydroxide, you would need 1 mole of sulfuric acid. And we know that we know the amount of the volume of sodium hydroxide, and we know the concentration. So the first thing we want to do really is work out how many moles of sodium hydroxide do we have. So if we have this, whatever volumes we have, we generally want to turn these into decimeter cubed, because you can see the concentrations are in decimeter cubed, but the volumes are in centimeter cubed. You could turn the concentrations into moles per centimeter cubed, but it's just a little bit more complicated. It's easier to do it this way, I think. So that's going to be 0.03. So you're going to move it 3 places. So it was there, 1, 2, 3. So decimeter cubed. Let's just use the formula triangle for this one. So we're going to work out the moles. So we want to do moles of the sodium hydroxide, NaOH. We want to know how many moles of sodium hydroxide do we have. Once we've got that, then we know we would need half as many moles of the sulfuric acid, because it's 2 to 1. Okay. So let's identify that first. Okay. So we've found the moles of the known substance, and I've just started to identify these stages here. So the first stage was to identify the known and the target substance. The known one was this sodium hydroxide. It's known because we have quite a lot of information about it. We have less information about that one, and we actually need to find out information about this one. So this is my target substance here, and I've highlighted them in the formula as well. And I've identified the ratio, but really we don't have to do that at that stage. But in any case, I did it at the beginning. We've used we then used the volume and the concentration to identify the number of moles. So that's stage 2. Find the missing value of the known substance. It's usually moles, and just like in this one here. Now, what you'll do then is you're going to use the ratio in the balanced equation to find the moles of the target substance needed to react. Okay. Right, good. So in this case, because it's 2 to 1, we've looked at the equation already and we've seen that it's 2 to 1. So the because we've got that many, it's going to be half as many of the. So we can identify that as going to be half as many moles needed for the sulfuric acid. Yeah, we've identified the number of moles needed to react with that other one because we used a ratio. So we're now down to the final step because this question is asking us what is the volume needed. Now we've got the number of moles and we've got the concentration, so we can use the volume. We can use those two to find the volume. Now we're going to get the volume in decimeter cubed, and it doesn't specify what unit to use, but I think it'd be good to be able to convert that into centimeter cubed as well. So we're going to calculate the volume, and then we're going to convert it into centimeter cubed. So yeah, moles divided by concentration, that's the amount in decimeter cubed, and remember that the decimeter cubed. So basically, 1 decimeter cubed is equal to 1,000 centimeter cubed. So we're going to simply just multiply that answer by 1,000.